Welcome to Daniel, who is, I believe, the head of protocol at Bluesky, and whatever you don't like about Atproto is his fault, I think. Is that accurate?
Yeah, that's right. Either my fault or I might blame Paul for it, but the stuff
Okay,
that you
or
like
but
is my
also,
fault.
yeah,
The stuff you
exactly.
don't
Whatever
like is
you
Paul's
like
fault.
about it is also his fault. So, Daniel, take it away from here. Thank you for coming.
Sweet. Yeah, thank you, Johannes. And thanks for Johannes came up to me at Atmosphere Conf, the developer conference for AT Protocol, and asked if I wanted to do this talk. And he noted that we didn't actually have like a talk that was just a technical introduction to the protocol. So thanks for offering to do this, giving me the venue for it, and thanks to you guys for coming to hang out and hear about AT Protocol. So yeah, this is basically going to be an introduction, a technical introduction to the protocol. We call it AT protocol or Atproto for short. I'll probably be saying Atproto during a lot of this talk. As Johannes said, my name is Daniel Holmgren. I lead protocol development and design at Bluesky. You can find me on the Atmosphere at this handle, theholmes.at. Uh, yeah, and sorry, I got these, okay, sweet. I was trying to get the faces out of the way. Yeah, so our goal with the design of AT protocol was to build a protocol for large scale open social applications. To like walk through that a little bit, the particular design problem that we like, or the particular lens we were approaching it through, is that we wanted users to have essentially the exact same experience that they would have on a traditional global social app. This is not necessarily to say that that's like the only way that decentralized social applications should be built, but we were coming in and saying, okay, users are familiar with a particular way of interacting with these apps. We want to be able to create that same sort of experience for them. So that involves global views over data, with tens of thousands or millions of likes, being able to aggregate interaction counts like that, search over the entire network, global search, giving users algorithms that direct their attention through content on the network, network-wide discovery, and having an experience of the app where they don't really have to conceptualize the network topology and where their account is in the network doesn't affect their experience in the app. But while we wanted to do all of that, we also wanted the benefits of building on top of an open decentralized protocol, which means permissionless participation, users being able to choose their service provider. For us, that means both where their data is hosted and the client or service that they use to interact with it. Account portability, so that if they don't like how their current service provider is treating them or they don't like their current experience, they can move their account around. And then this interoperable data layer where any application and any person can tap into it, kind of remix the data or show it in a different context or light. So I'll give the basic shape and intuition, and then we'll kind of like dive into each of the pieces of the protocol and reconstruct this as we go along. Like every technical diagram, this is way too many arrows and probably looks scarier than it maybe is. So the core intuition around AT protocol is that we sort of have this split in the network between generic data hosting and then and a richer application layer that builds on top of that generic hosting. So we have this open, remixable, crawlable data layer. Those are the personal data servers here at the bottom. That data gets crawled by services that we call relays and output into a global firehose of all of the data in the network. That firehose can then be consumed by applications, algorithms, moderation services, developer tools, whatever it may be, to build the rich application views that you expect. At the hosting layer, this is kind of dumb, generic JSON CBOR. It doesn't actually have application value. It's only after it gets crawled, sucked up, and indexed into an application that it gets imbued with like sort of the richer application semantics that users expect from social. Uh, Currently, all data in the network is public, and it's like manifestly public. It's anybody can crawl this and see this. And sync is all pull based, so it's personal data servers are hosting this, and then things go out and crawl the servers and pull from them. Personal data servers never have the responsibility of pushing their data anywhere. So this is a rough roadmap of what we're going to go through. We'll talk about identity, how our accounts identified in this system, the data model of Atproto, records, and then the repositories that hold them. We'll walk through each of those services that I talked about, the personal data server, the relay or firehose provider. We'll talk about lexicons, which is the schema system, OAuth in the network, how applications authorize access, um, the role of applications and kind of the steps that you would take as you're building the applications. And then we'll talk about the atmosphere, which is the term that our community has come up with to describe all of the applications built on top of AT protocol. So identity in the network, every user is identified by a DID or a decentralized identifier. That's a W3C spec. I think most folks from ActivityPub are probably familiar with it. Uh, and your DID is basically a universal identifier that then resolves to a document containing some information about you. Inside of that document is going to be a pointer to your personal data server where your data can be fetched from, a signing key that's used to authenticate the data that gets fetched from that server, as well as a handle, which is kind of the human understandable translation of one of these universal decentralized identifiers. The handle is then bidirectionally linked back to the DID, which I'll give an example of in the next slide, and that forms this one-to-one mapping of DID to handle and handle to DID. Right now, DID is this like kind of massive open. There's hundreds of different DID methods that gives a pretty big operational burden to anyone that wants to support DID. Right now, Atproto sort of has two blessed DID methods. One is DID Web, the other is DID PLC. PLC, it stands for Public Ledger of Credentials, and it was created by Bluesky to kind of like fill this role that we needed for it. It's currently operated by Bluesky, and I'll talk for a second at the end about the governance changes that we're making related to that. So this gives like a quick example of that bidirectional linking. This is what you might see if you resolve this did at the top on the left. You can resolve it by curling PLC directory. You can see the pieces inside of it, including the handle, the signing key, and a reference to the personal data server. This is my did. And then the handle, and also known as dholmes.at, gets bidirectionally linked back to the did through DNS. I publish a DNS record at _@proto dot whatever the handle is, just a text record that links back to the did. So anytime you want to like resolve a handle or did, you can do this bidirectional link between the two to figure it out. There's another mechanism for linking your handle back to the did, which operates over HTTPS through a well-known endpoint. So you can do either one of those mechanisms, either DNS or HTTPS. So the data model of Atproto is based around these units that we call records. Everything that a user does or creates is a record. So posts are records, but then interactions like likes or follows are also records. Reposts are records. Replies are records. Profiles are records. Everything that you do in the network is a record that you publish to the network. And they're all held in your repository. So if you're replying to someone else's post, that your reply stays on your server and is held in your repository. It doesn't get sent over to their server. Records are just typed JSON or CBOR objects, and they're addressable or linkable by an AT URI. Below, I have like an example of what one of those URIs looks like. And if you were to actually resolve this URI, you would find a like record in my repository. You can kind of get a sense for what a record feels like, which is it has this $ type that describes what this record is. In this case, it's a like, and I'll talk about this exact syntax, the reverse domain name thing, in a second as well. It tells you the type of the record, what this record is, and then some things in the record. In this case, it's a like has a subject and is created at a particular time. So this has the date that the like was created, and then it has a reference to the post that it likes. It references it using AT URIs, so we build up this linked network of data, as well as CIDs or content identifiers, which are essentially a hash of the data that give you referential integrity for any interactions that you create. So every single record has an AT URI, can be addressed by an AT URI, and then can be resolved using that URI. URIs have three parts. One is the did of the author. The next is the collection or the type of the record. This basically lets you know what you're going to be getting on the other side of resolution before you go and resolve it. And then a record key, which is kind of an opaque or arbitrary string. In a lot of cases, we use this format that is essentially derives, it's like a base 32 encoded version of a timestamp. But it can be any sort of string that you put in there as a record key. Uh, and then these records are all stored in repositories. Each user has a repository that contains all of the records that they've created. They can delete records out of it, they can update records in it, and they can obviously insert new records into it as well. Repositories are signed. They basically take the form of a Merkle tree, which I'll walk through a little bit of what that is in the next slide. And they're signed at the root of that tree. So one signature authenticates all of the records that a user has published currently. And then they can be broadcasted out and sort of efficiently synced. The reason we sort of had to make this choice between, are we signing the records or are we putting them in this container, the repository? And the reason that we decided to have the repository contain all the records was basically two reasons. One, it gives you sort of positive proofs of deletion, and you can say, look, here's a Merkle proof showing that this record is not there, so you should delete it out of your index, or showing that an update occurred, um, and that the old version is now like deprecated, and you should delete that. And they also give this like quality of completeness or coherency. Like at any given point in time, you can say, what is the current state of a user's repository, and sync exactly what that user has. So this prevents you from having to do something like run out and say, okay, well, I have these, 500 pieces of content from this user. Am I missing anything? Did any of these get deleted? Do I have to find a tombstone somewhere? Anything like that. This just says, nope, there's one hash that this all boils down to. If your current copy of a user's repository boils down to that same hash, then you have their exact set of data. There's no ambiguity there. So and I won't get in too deeply into this, but the actual data structure for the repository is this thing called a Merkle search tree. The basic things to know about it are that it has a probabilistic construction. So the construction of it is based off of hashing the keys and then counting the number of zeros at the front of the hash. And even though it has that probabilistic construction, it's also deterministic and order independent. So any collection of records that you put in, it doesn't matter the order that you put them in. If you had deletes or updates or anything along the way, if you have a set of records, that will always have the same root hash. Uh, Using that, we get a pretty efficient delta-based sync protocol where we can send out just the delta whenever a write happens, and you can verify that you reach the exact same root hash that the user currently has published. And one of the big benefits of the Merkle search tree is that all of the records are laid out in lexical order. And we use that so that if you remember, the collection is in the AT URI. We use that so that everything in a collection is laid out next to each other in the tree. And specifically, even within a collection, things that were created at a similar point in time are laid out next to one another. What that gives us is pretty good structural sharing for proofs. So you can sort of sync slices of a repository. If you care about certain pieces of the repository, like a certain application and not another application, you can sync just the pieces of the repository that you want. So then these repositories are stored on personal data servers or PDSs. The role of a personal data server is to host both the user's account and the repository. And it makes that repository accessible to anyone that wants to crawl that user's data. But then the PDS is also the place that a user logs into. It's sort of their like home base on Atproto. It serves as a OAuth authorization server for any application that they want to use in the network. PDSs are pretty cheap, simple, and commoditized. They're very easy to run. I personally run mine on a cheap, I think $4 VPS, and hardly use any of the like resources on it. So they're pretty cheap to run, and that's because they have a simple role. We wanted to keep that role simple so that it's easy for people to run these for themselves. So you can either self-host or you can use a provider. Bluesky provides large Bluesky or large PDS instances, for instance. Um, as well, account migration is a native first-class feature of the protocol. So it's fairly easy. We can make it easier from a UX perspective, but technically it's fairly easy to migrate between PDSs. You essentially will update your did document to point to a new signing key and a new location, create an account at that location, and move everything over. Because everything is addressed by these universal decentralized identifiers, all of your backlinks stay the same. we actually have had the experience of people migrating their account and thinking they screwed up because nothing changed. They kept using the app and they're like, nothing feels any different. And that's because all of your follows, all of the backlinks, everything remains the same whenever you move over to this new location. So then, because you have all of these personal data servers in the network, that can be maybe somewhat complex for an application to crawl and know where they all are whenever they're coming into the network. So we've carved out this role in the network of a relay, which is essentially a firehose provider. Um, so every PDS offers a real-time event stream of all the repository rights over a WebSocket. So anyone that's crawling these PDSs can subscribe to a WebSocket for a PDS and get every single write that's coming out of that PDS pushed over that WebSocket. What a relay does is it goes out, finds all of the PDSs, subscribes to those event streams, and verifies the writes that are coming over it and collates it into one big outgoing stream. This lets applications, algorithms, moderation services, or anything else in the network subscribe to the relay and get everything in the network. Or even some like filtered segment of it that isn't filtered based on PDS, but maybe filtered based on, what application the users are using or something like that. Relays ultimately serve as just a sync optimization in the network. The network could, from like a data modeling perspective, like function without relays. But relays are sort of this facilitator that makes sync easier to do and makes it more approachable for applications or algorithms or something that want to come in and provide some service without having to, figure out the network topology and keep track of everything that they want to crawl. So you probably saw this weird domain name thing in the AT URI, app.bsky.feed.like. That is a reference to our schema system, which we call lexicon. Lexicon was pretty closely inspired by JSON schema. We actually wanted to just use JSON schema, but there were a couple of things that were really awkward to do with it in the way that we needed. So it has a lexicon is essentially JSON schema with some extra accommodations for extensibility of schemas. Um, Lexicon types both records in the network as well as API endpoints. It kind of gives you this, in some ways, it's a little bit like gRPC, sort of, kind of, in protobuf, but again, in a way that's made for extensibility and for other devs to kind of remix or experiment on top of these schemas. So lexicons can both describe records as well as API endpoints in the network, and they're identified by this reverse domain name syntax. We call them NSIDs, or namespace identifiers. You can see a few of them here. Bluesky posts, app.bskyfeed.post, site.standard.document. That's a community-led blogging schema. In the atmosphere, community.lexicon.calendar.event. That's a community-led calendar event lexicon. And lexicons themselves are published and resolvable as Atproto records as well. You can see an example of a lexicon over here on the side. This is just a schema for likes in the network. And you can kind of look at the pieces of it. It says that this is going to be a record. It requires that it has a subject and a created at time. The subject is a reference to another record in the network. And then there's an optional value of via that, for instance, if you're liking a repost, you can encode the fact that you like this post by virtue of the fact that it was reposted by another user. So anyone can publish a lexicon and anyone can use a published lexicon. Lexicons essentially serve as this like social coordination layer for application semantics. They let you know what to expect on the other side of it. They let two applications know that they're talking about the same data, and they kind of give you this like contract for interoperating between applications. Lexicons are specifically intended to evolve over time, so you can make updates to them. You can push out those updates. We have a set of guidelines for what types of evolution can happen over time that basically keep stuff backwards compatible. And then lexicons may include open extension points. So that's something we call that's the main feature that we added over JSON schema, is a type in the schema called an open union. And inside of that open union can be different, essentially sub-lexicons inside of it. A good example of an open union is posts on Bluesky. Those posts might include images, they might include video, they might include link embed cards. Those are all things that Bluesky talks about, but someone else may publish a um, schema that describes a different type of embed that isn't necessarily created by Bluesky. Like they can extend the lexicon in a third-party way, and applications can choose to implement that third-party functionality. So as I said, PDSs in the network are all OAuth authorization servers. We Atproto uses a particular flavor of OAuth that there's a whole maze of specs here, but it's essentially OAuth 2.1 plus Depop plus PAR plus client ID metadata docs. Client ID metadata docs are kind of the like big new thing here, sort of. The big problem is that there are many authorization servers in the network and there are many clients in the network. So you have this N by N problem. And how do clients register with authorization servers? And that's what this client ID metadata document specification provides, which is essentially lazy client registration. Kind of clients, in some sense, like register on the fly as the user goes to log into them. They basically provide this document that gives metadata about the client that then the PDS can sort of make sense of. Because we're in this like crazy N by M world of clients and authorization servers, that's the reason that we included things like Depop and stayed pretty true to OAuth 2.1 and really kind of like nailed it down and did all of the belt and suspenders things that you want to do with OAuth to lock it down and make it sort of as safe as possible in this kind of crazy N by M world. And then the actual scopes that you request through OAuth are declared through lexicon as well. That's a particular type of lexicon, which we call a permission set. And that basically lets an application developer um, give a bundle some particular scopes together and give a human readable explanation of that. So the OAuth screen that I have here is an example from an app called Margin that lets you sort of make notes. It's a browser extension that lets you make notes in the margins of web pages that you go to. But you can also log into Margin to see the notes that have been made. And you can see here the text of a permission set that they made, which is that if I log into Margin, I'll give full access to Margin features, including notes, replies, likes, and collections. So this gives a way to make legible to users what they're actually giving access to whenever they log into an app and kind of make sense of these applications that they're using, even though they're getting presented by this generic personal data server that doesn't necessarily have the application knowledge to tell them what they're doing. So moderation in the network is handled throughout the network. Different services that participate in the network ultimately have to make decisions at their discretion and make decisions under their purview. So PDSs, for instance, are in charge of hosting users. And so PDSs have the discretion to decide who they want to host and can take down a user, they can suspend a user, they can kick a user off of a PDS, basically refuse to host them anymore. Applications, on the other hand, are crawling this PDS layer, and ultimately they can decide what they want to crawl, what they want to index, and what they want to serve. And that decision that they make doesn't necessarily get reflected down to the PDS hosting layer. So if, for instance, if a user is spamming a particular social network, that social network can decide well, we don't want to show any of the spam, so we're just going to stop crawling that user. We're not going to index it, and we're not going to serve that to our users. That doesn't necessarily reflect down to the hosting layer, to their PDS. However, if the application is also running the PDS that that user is hosted on, then it may reflect down into the PDS hosting layer. And then labels are a way for either applications or other folks in the network to annotate data in the network. So for instance, with Bluesky, many users run moderation services that publish labels in the network. Those labels are then ingested by the application and can affect how that content shows up in the network. Labels themselves are signed more free-floating units of data. You can see on the right an example of one of these labels. This is in particular a label that labels a given post as being spam. And then applications and clients can decide what they want to do with those labels. If a user subscribes to a given moderation service, that label may cause the content to be hidden. It could give a content warning. It could badge the content with something like, could badge it saying that this account is a impersonation account or that this account is spreading misinformation or something like that coming from a given moderation service. So labels kind of give this like flexible moderation system that can be deployed on top of the infrastructure moderation that happens in, for instance, the PDS layer. So bringing all of this together, if you were to build an application on Atproto, there's a few steps that you have to do. The first is you want to describe the data model that you want to work with. That data model might be new application semantics that you're coming up with, in which case you want to design some lexicons and publish those into the network. You may want to use data that already exists in the network and use lexicons that have already been published into the network. And you don't have to make a binary choice between those two. You might use some data that's out there already and then layer some of your data on top of it. Then you'll want to deploy a OAuth client for users to interact with. That OAuth client describes itself through this client metadata document, and you don't have to go around registering with PDSs. That kind of happens on the fly or lazily as a user logs into your OAuth client. Through that client, you'll have an OAuth credential that you use to write your data to the user's PDS. And that data then gets crawled by relays in the network. And so your application will then want to subscribe to a relay to crawl any data coming from any user's PDS that's creating it in the scope of your application. So you'll crawl all of that data, index any relevant data, and then use those indexes to serve views of application data. So I'll call back out that divide that we had from the initial graphic, which is you have this open generic hosting layer made up of personal data servers. This is where the canonical data is stored. This is where the signed data is stored. It makes it hyper crawlable. It makes it very easy to access that data. And the signature translates through multiple hops. So a relay can go out and crawl all of this, provide a unified stream for all of the data. Then applications, developer tools, algorithms, moderation services, kind of this rich ecosystem of applications can subscribe to one of those relays in a permissionless way and use that data to give you kind of the traditional social media experiences that you expect. These applications can kind of scale as far up or as far down as they want. You can choose to index just segments of the network if you only care about a particular segment of the network, or you can choose to index the entire network, in which case you're going to be indexing billions of records and terabytes of data. And obviously the resource cost scales depending on what you want to do with the data. I did want to call out, Evan talked about this a little bit, but AT Protocol and ActivityPub are currently bridged with each other and work well together, which is super exciting. A huge shout out. I think I saw Anuj in here, but a huge shout out to Anuj and Ryan Barrett for working on this. It's just awesome to see. If you want to check that out and you want to be bridged between the two networks, go check out BridgieFed. And a little word about what's next. I'm super excited to announce that AT Protocol just got a working group at the IETF. Our first working group meeting is going to be at the next IETF meeting in Vienna this July. There's a mailing list going on about that. If you're interested in this work, I'd highly encourage you to check out that mailing list and hop in and discuss it. Everything that I talked about is not in this working group. The particular piece that this working group is built around is the data model, so records, repositories, ATURIs, and kind of we didn't want to pull DIDs into it, but there's an identity shaped hole in the spec, and we're specifying the shape of that hole. Also to talk about PLC for a second, that's like a somewhat controversial piece of the stack because it is somewhat centralized and at the bottom of the stack. I encourage people to read about PLC. It's a self-certifying DID method. There's a very limited attack surface for the centralized directory, but it still is the fact that it's a centralized directory. We also recently just formed a independent association to operate and run PLC. That's a Swiss association. We have a very credible, in my opinion, and neutral board on that. I'll give you a pointer to where you can read more about that. But there's 5 people on the board. They're very well-respected cryptographers and security engineers. There's only one person out of those 5 from Bluesky. Over the course of the next few months, we're going to be transferring assets, including the domain, as well as operations of the directory over to that association. And then, as I mentioned, everything that I talked about today is the public data protocol for Atproto. We're currently working on the design for a permission data protocol as well, which basically gives access boundaries over data and lets you do anything from personal data like mutes or bookmarks or drafts, all the way up to communities or private groups or private forums, things like that. I'm documenting the design work that we're doing on my blog, which you can see at that URL. Um, in a I'm calling it a permission data diary, basically reconstructing the pieces as we kind of like work through it. So if you're interested in that, you can follow along there. Um, and as I mentioned at the beginning, this was kind of like a more technical introduction to Atproto. These are a few other resources if you want to learn more. There's a great talk from Dan Abramoff called "A Web Without Walls" that kind of gives a sense for what the atmosphere is from the perspective of like problems that have emerged in the web and Web 2.0. A talk by Devin Ivey about the shape of apps to come, what application development actually looks like on top of App Proto. And then a long blog post that I did called App Proto Ethos, which kind of gets into the maybe like philosophical and aesthetic principles that we had in mind as we were working on the design of this protocol. And then I just recently gave a talk about protocol governance and hard decentralization just a few weeks ago at Atmosphere Conf. If you're interested in things like the IETF, the new PLC association that was formed, and also kind of some like threat modeling about what it means to be building a decentralized network whenever there currently is an outsized large actor, Bluesky, operating in that network, and what the network can do to ensure its resiliency. Yeah, so with that, I'll open it up to any questions. I'd love to chat with you guys about it. And I'll stop sharing too so we can actually see each other.
Daniel, appreciate it very much. You gave us the speed run through a thousand million things in here. I hope people were not entirely left behind because there's so much in it. But this is great. I wanna highlight that last link you just had there in your last slide about the thread model. I was in your talk there in Seattle, and I have never seen in the history of technology or any other history that I'm aware of that the employee of a company goes to a public conference and says, "And this is how we defend against my employer going evil." I was thinking sitting in the audience, all the world's business school professors just had a heart attack because this is not how this is supposed to work. But it is
Right.
good that you're doing this, so we have great commendations to you for doing this kind of stuff. If I may maybe ask the first question, which is that yeah, obviously Blue Sky sort of started this entire project as Blue Sky, but it has become a community kind of thing. There is a lot of other people involved. Some are parallel infrastructures essentially that are being built bits by pieces, and then there's also innovation happening that's in some way um, um, there's a complementary, but also perhaps somewhat overlapping innovation happening, such as permissioning data, where there is all sorts of proposals out there, as far as I know.
Mhm.
How do you see over the next so many years? How do you see Blue Sky working with the community? How how does innovation happen? Who innovates? Because the ITF process is a little bit at the end of this, where then finally, the consensus gets basically codified, but it's not necessarily where the leading edge innovation is going to be done. And how these systems that people build like Black Sky and Your Sky and all that, how do they relate going forward?
Yeah, that's a great question. And I mean that's something that we're like actively thinking about and sort of evolving our thinking on. It's like it's incredibly awesome and honestly humbling to have this entire ecosystem of devs that are super excited to be building on this protocol. And people are kind of just getting in there and getting their hands dirty and building on it. As I said, there's like no permission required for that, and so people kind of just hop in and start working in there. In terms of like proactive protocol design, I mean, lots of people are again kind of just hopping in and building random things. For instance, Lexicon Community is a community-led effort for designing some kind of generic or like standardized schemas that different apps can use. They have those specified around events, bookmarks, um, a few others that I'm like blanking on exactly what they are, but kind of like more generic schemas that people can use. That was just a completely led community effort. They've put together a community steering board for that. That's really exciting to see. For new larger protocol features like permission data, as you mentioned, there's a few different folks in the network that are working on that. The names of the ones that I'm most familiar with are Black Sky, North Sky, Habitat, and Rumi. Everyone sort of has like a different take on this. I think a lot of them are pretty complementary to what Blue Sky is working on with our proposal, or even either map on top of it or essentially just work with it. So I'm like talking pretty closely with all of the folks that are working on that, and we're sharing, like we're all kind of working on our own implementation right now, sharing what we're finding out along the way, getting feedback from one another on it, and hoping that these can all work with each other as we get to it. We don't want to have like a overly formal governance process or like working group process for getting this set up. Like the goal is to kind of get this protocol um, like specified and hopefully out there in the next 6 months or so. If we were to do this in some sort of venue like the IETF, it's just not feasible. That's like a multi-year process. So we want to do it a lot lower overhead than that. But the entire process we're trying to do in tandem with our community, get their feedback on it, and work pretty closely with them on it.
We just go with the hands up. Bring your questions. I think only one hand up. Kagan.
Uh, Thanks for the presentation first. And I really have to note that I really enjoy using Blue Sky and the protocol under hood. And my question is, and actually the only issue I have with the Blue Sky and the AT protocol overall is how private are anything. Because since everything goes through a firehose and everything can be indexed by literally anyone, it creates a huge privacy issue in my opinion. Because sometimes we just want to delete content or have something deleted, but unfortunately this is impossible as any application can index, and instead of deleting a content from their index they can just label it as deleted. How, or are there any plans, first, are there any plans on working on this, and if so, how are you going to work on this? I wanted to ask about it.
Yep, that's a good question. Thanks for asking. We are currently working on it. We're working on a permission data protocol that will provide those access boundaries for data so that not everybody can crawl it and it doesn't get blasted out to the entire world. That'll facilitate things like communities or private accounts or, gated content, or even just personal data, things like that. So yeah, we are currently working on it. Right now, everything is public and it's manifestly public. It's very public. As you say, it gets broadcast out to the entire world. We sort of thought about that in terms of the open web, which is like, for us, it's actually an anti-pattern for PDSs to sort of block certain people from crawling it in the same way that the open web kind of wants to keep things open and not block certain clients or certain browsers or something from accessing that data. So yeah, we intentionally made the public protocol sort of very public, made the data rebroadcastable in an effort to keep it locked open. And the resolution to that is a separate protocol for permission data that gives you the ability to put boundaries on your data.
Jim.
Thank you for this excellent overview. I'm a novice and this is very helpful for me. My particular hobby horse is user identifiers which are non-ASCII, not limited to Latin script letters. So could you remind me where in the architecture is the human readable identifier located, and can that identifier consist, the human readable identifier consist of scripts other than Latin script, languages other than Western European languages? Like a Hindi name, for example, if I want to use a Hindi identifier, does that work?
Yep.
Does the protocol let that work?
So the human readable identifier is the handle, which is essentially a DNS name that gets mapped to it, that gets bidirectionally linked to a did. And you can essentially do whatever you can do with a DNS name with that, which my understanding is the limitation is essentially puny code, and then clients and applications can make the decision of if they want to show that as ASCII or as the Unicode character, whatever script that character represents.
Thank you.
Samir.
Hey, Daniel. So
Hey.
I have a question about schema validation. Is there any like a lot of times you find a lot of garbage in PDS, like in a repository when you get it? Is there, and I know there is some sort of validation as you put things into the PDS, but is there something that validates a schema is accurate and correct more so than the basic stuff, or is that the responsibility of the app developer that is inserting records or translating those records?
Yeah, that's actually a really good question, because there are a couple layers to this. There are some things that are defined in the data model, like certain things that are just not supported in the data model for records. So like records of a certain size, I forget what the exact size cap is, but like 1 or 2 MB or something like that. I'm blanking on like some other rules for that, but there are very few rules that are kind of that exist generically in it. The PDS right now does enforce that the collection has to be the same, that every record requires a $ type that says what the type of the record is if you're just looking at the record, and that type has to be the same as the collection. But obviously somebody could have a PDS implementation that doesn't enforce that. So, and that's kind of the answer to a lot of this validation stuff, is that this is a permissionless network for anybody to participate in, and so kind of anyone can jam whatever they want in a record, and it's up to the people crawling it to realize that it doesn't match what you're looking for and to discard it or throw it in the trash. But there are a lot of things that the PDS can do to kind of come in and try to prevent the creation of garbage data, which our PDS distribution does try to do. Like certain data limits, that comparison of type and collection. And then since we introduced this lexicon resolution system, what we want to do is have a cache of resolved lexicons that whenever you do a write, your write gets validated against those lexicons on write, so that the PDS can kind of give you like proactive feedback if you're writing a bad record, and it can help the application from distributing a bunch of bad content. Ultimately, it's like these checks have to exist throughout the system. People reading it have to validate the content to make sure it's what they expect. PDSs can give proactive feedback, and then an application needs to be aware of what data it's trying to write so that it can write the correct thing. So the answer is kind of. And everybody has to do it, unfortunately. That's the downside of multi-party systems.
Lawrence.
Hey, great talk. Thanks. I have one softball question and one non-softball question, because
Nice.
like Johannes said, I really appreciate your presentation at the Atmosphere Conf as well, where you went over multiple threat modeling, and I think of multiple threat vectors and how are you dealing with that? And I think it would be nice to pick one of the ones that you think is most relevant and explain that to the audience a little bit as well. And the second part to that is spoil a little bit, you multiple times you gave us an answer of what we need as protocol creators is a thriving network. And how do you balance that as specifically as a team of protocol developers who do the actual technical stuff, but for your team to succeed as developers, you need a whole lot of social systems to, you need other people to actually start building. How do you manage that, and how do you deal with that when your tools are basically more code? But the problem is not more code, but more people to do stuff. And how do you balance that?
Yep. Cool. Two good questions. Okay, let's see. On the threat model. So the obvious threat model is the Bluesky app getting bad and shutting down. It's we have this ecosystem of clients that just subscribe to our API, for instance, and us shutting that down. You see that example from sort of traditional social apps, Reddit, for instance, shut down Apollo. So that's sort of the obvious threat model that people think of with social media. And that sort of has the obvious solution with the protocol, which is that all of the data is open, so somebody else can just subscribe to that exact same data and provide the exact same API on the other side. So that's kind of like the obvious answer to it. But then the question is, okay, what if they can't have access to the data? And that's like the more interesting threat model here, which is what if Bluesky shuts down access at our PDS and stops providing the open public APIs to the data and to keep applications from accessing it? And that gets to what your second question is, which is we sort of have to align the incentives so that large PDS providers like Bluesky are incentivized against doing that, which means making it so that it hurts our business model if the data is not open. So right now, for instance, we have this ecosystem of open feeds in the network that provide different custom algorithms or community-based feeds or interest-based feeds on top of data. And if we cut off all of those derive off of the firehose from the relay as well. So if we cut off access to open data, we wipe out that ecosystem of feeds and users lose one of the defining product features of Bluesky. Right now, is that good enough that Bluesky could not do it if we like really, really wanted to or decided to? I'm not sure. But as we build this ecosystem of algorithms and moderation services and other applications in the network that all derive off of the existence of this open data, I think it pushes that incentive further and further to make it so that large hosting providers aren't able to cut off access without completely destroying their own business and business model. So that kind of like takes me to your second question, which I think is like, how do we balance this? I'm actually not quite sure if I understood it, but it's like, how do we balance this, like the protocol development that we're doing with also trying to steward this network of open applications?
Yeah, like it's sort of a social problem as well. Like I
It
picked a
is.
slide, like you need a thriving network to built on open data, you say in one of the slides, and like,
Yes.
but your tools as specifically in the protocol team is like more protocol and not necessarily more people. And how do you balance that?
Yeah, that's it. Yeah, and I mean that is like the hard question because it is a social problem and it's not something that we can. It's like actually impossible for us to solve that. All we can do is like try to help steward this. I think the answer is kind of like just telling an exciting story of what you can do using Atproto and how it's different from how the web works right now, and it like like anyone can hop in here and build with it, and it's like really fun to do, and you can build really cool stuff that just like kind of can't exist otherwise. And then we sort of have a unique position where we do have a larger social application with millions of users, and we can provide a distribution channel to some of those applications as well. And which also kind of paints this picture of what it looks like to have a ecosystem and a network of a bunch of interconnected apps. So that's something that our current head of product, Alex, is pretty interested in doing. And we've been doing integrations with different apps in the ecosystem, like a live streaming app called, oh my God, my brain just.
Oh, your brain's fried. Streamplays.
Streamplays. I wanted to say live plays, and I knew that wasn't right. Streamplays. Streamplays that we just integrated, an end-to-end encrypted messaging app in Germ that we just integrated. We're currently working on an integration for the open blogging standard site. So just kind of, I think I might have just given away a secret with that one, but kind of like demonstrating some of how this open ecosystem of apps can all integrate together into a unified experience.
William. I think it's William, right?
Yeah. So I guess my question, so when AT was being rolled out, I totally understand the concern that AP was not able to provide as great of an experience, right? And so AT was kind of rolled out to, have a more global view and to provide search. And if I understand correctly, a lot of what Bluesky does, a lot of enabling that comes through the app view. And so then the app view ends up having to be the big, and it's the big costly thing, and it's very powerful. And kind of Bluesky wants to then ultimately be the biggest one, because that ends up having the greatest, the greatest service for users and all that. And I guess what I wonder is like, how does that not create a long-term centralization issue where Bluesky is always going to try to be the biggest one because it's going to provide the best experience and thus it's going to get more people there, and and ultimately there's the VC issue or whatever. But ultimately there's a desire to be the big guy forever. And how do you solve that, I guess?
Yeah, I mean that's a really good question, and I would, if you're like interested in engaging with that, I'd encourage you checking out that protocol governance and hard decentralization talk that I gave,
I've got that
because
saved. Yep.
am
Okay.
awesome. I do try to get into the heart of that. But I'll give an answer now, which is we are encouraged to be like the large provider in the network, but we're also encouraged to try to steward the existence of this open network. And so just I'll say personally that everyone on the Blue Sky team is like very ideologically aligned with the open network, but obviously that doesn't necessarily translate out to wider people. But so like the cynical argument is that like from a business perspective, we're much more interested in the existence of this larger network because it's like kind of a like rising tide lifts all ships here. And like Blue Sky as a like company and an app is much more valuable in the context of this wider network of open applications. And so then it's like, okay, but how do we prevent ourselves, or like, why would we not end up shutting down API access or shutting down access to the data? And that kind of gets into the threat modeling that I was going over with Lorenz, which is that if a bunch of people are building on top of open data, and that's really where we're deriving our like business model from, and like where we're deriving like the product value from, then we're incentivized not to shut down that
Right.
layer
Well,
of open data
I'm not
without killing
concerned
that
about
product.
I'm not concerned about shutting down, but like when Corey, Corey talks about enshittification a million times, right? He says that
Mm,
Google is actually the worst example. And Google, in my view, is completely built on open protocols, right? The only thing is that they want to be the place that everybody goes through to deal with those open protocols. So you have Gmail, you have search, and so like, but he says they're a problem, because of all the other things that they cause a problem for, right? So I
yeah.
guess I just see Blue Sky naturally fitting into that role where they never go evil in a sense, but they end up causing all these other problems because they end up being the big guy who is always going to be ultimately the biggest guy around just because of naturally it's first mover advantage, or it's
Yeah.
already being big, and then and money starts rolling in. However, monetization comes by being the big person. You get to monetize, and so
Yeah.
it's never total evil, but it has side effects that create that have what we've seen, I think, on the web lead to things that we didn't really want to see on the web. And I'm worried we're going to see that in social web, especially if in the dream world, all the different services end up, using Atproto. And then it's not Blue Sky, isn't Blue Sky's competing against Twitter and Facebook, but ultimately we want them to be the dominant one and all those other Twitter and all of that to be part of that. And Blue Sky then being bigger than all of it. And I mean that's ultimately the vision of a completely decentralized web is all those players are part of the whole thing. And if Blue Sky ends up being the biggest one of all of them, that's really dangerous the way I look at it. So
In the
Yeah.
interest of time, we are almost out of
sorry.
time here. Maybe Daniel, you can respond as you like, and then we have two more people in the queue. But we also don't want people to die of not being able to grab a snack or things like
Okay.
that before the next session.
I'll give a really quick response, which Blue Sky will like almost will certainly enshittify at some point. So it is correct to like think about what that looks like. I think that there are different failure cases for like Atproto app views in shitifying versus like SMTP servers or web crawlers. And specifically because SMTP servers are like this push-based thing, it's just a pretty different network architecture than crawling. Like I actually think the Google search monopoly is a better monopoly than like the Gmail monopoly. I prefer the web monopoly. And then but then the threat model for Atproto is less than the Google model because all of this data is signed. It's hyper crawlable. It's really easy to access. It's cheap to access in a way that crawling the web is much more expensive and difficult. And then it's all signed and can be rebroadcast, so you can get it from a bunch of different locations. So basically, like there are economies of scale in this, and that doesn't necessarily mean that it's easy to create a Blue Sky app view, but I do think it's like probably like a couple orders of magnitude easier to do like an app view in the network than it is to do a web search engine. So I just like I have the same concern, but I think the threat model is a little bit different for these different protocols.
Paul, you have a quick one?
Quick one. Could you repeat what you said to me in Vancouver, which I asked you if the did PLC method or the infrastructure, if we also incorporate this in ActivityPub and Fediverse networks, is that a good idea?
Yes.
Do you welcome that?
Yes, we totally welcome it on the did PLC side. From our perspective, it's like a generic did method, same as any other did method. If you find it useful, I'd highly encourage you to use it. Of course, only use it if it's useful. You should only use it if it's useful. But if you think it's useful, then definitely use it.
Jim,
Thanks.
final question.
Quick follow-up to my earlier question about globally inclusive handles. Are you aware of people actually using such handles, not limited to Latin? And would it be reasonable for me to write an app to read a firehose and look for such handles?
I am not really familiar with people using it. The Bluesky app currently doesn't translate Punycode to Unicode characters. I don't believe. But yeah, it would definitely be reasonable to search the firehose to see if you can find some examples, or to look through the PLC directory. That's actually probably the simplest listing of a bunch of handles. Easiest to enumerate.
And that, I
Thank
think,
you.
brings us to the end of our session here. Thank you very much, Daniel, for telling us all these things and answering all these questions. And we have recorded this, and we will publish it as soon as we can after this event. And hopefully,
Awesome.
I think
Thank you guys for